My name is Jasmine Naura. I'm from Group 7. I want to answer a question number R27 and problem number 2. In a TCP-based client-server application, the server must be executed before the client because TCP requires a connection-oriented communication model. Here's why. 1. Server listen for connection. In TCP, the server must first be running and actively listen for incoming connection required via listen, system call after bind, and socket. Number 2. Client need a server to connect to. When the client attempts to establish a connection using connect, it must contact a server that is already running. If the server is not running, the connection required will fail because there is no active process listening on the specific port. Number 3. Three-way handshake. TCP uses a three-way handshake to establish a connection. If the server is not running, the handshake cannot be processed. In contrast, in UDP-based client-server application, the client can be executed before the server because UDP is connectionless. Number 1. No handshake required. UDP does not establish a persistent connection before the data is sent. A client can send a message even if the server is not running. Number 2. Base effort delivery. If the server is not running when the client sends a message, the message is empty and simply lost. But the client does not experience an immediate failure like in TCP. Number 3. No need to listen for connection. Since UDP server do not need to especially accept connection, they can start at any time and begin receiving package as they arrive. I want to answer question for problem 2. The primary distinction among SMS, iMessage, WeChat, WhatsApp lie in their underlying protocol and operational framework. SMS is traditional, carrier-based service that transmits message over cellular network without requiring internet access, but it lacks advanced feature and robust security. In contrast, iMessage, WeChat, WhatsApp are internet-based services that overreach multimedia capabilities and enhance security measure. iMessage is exclusive to Apple ecosystem and integrates seamlessly across Apple device. Now, supporting RGS for the border compatibility. WeChat serves as an encompassing platform with a wide array of services beyond messaging. Primarily catering to the Chinese market, WhatsApp provided a straightforward message experience with end-to-end encryption supporting diverse global user base across multiple platforms. That's my answer for question number R27 and for problem number 2. Thanks.
Hello, my name is Levia Widjaya. I'm from LB8C, which is Information Technology. Today, we'll talk about my answer for question R25 and P5. Let's begin. Question R25. Besides network-related considerations such as delay, loss, and memory performance, there are other important factors that go into designing a CDN server selection strategy. What are they? When picking a server for a content delivery network, as we know as CDN, you have to think about more than just speed. Here are some important things. 1. Server location. Closer servers makes website load faster. CDN use each server near users. 2. Content type. Different content needs different servers. For example, videos need streaming servers. 3. Server load. Busy server are slow. Choosing a less crowded servers helps us. If backup server or failover. If one server stops working, another takes over. 5. Cost efficiency. Managing server costs and data transfer fees is important. 6. Performance check. Check speed and traffic to keep things running well. 7. Testing and fixing. Find problems and improve servers by running tests. Okay, question number P5. The text below shows the reply sent from the server in response to the HTTP. Get message in the question above. Answer the following questions indicating where in the message below you find the answer. A. Was the server able to successfully find the document or not? Okay, the response status on HTTP 1.1 OK. That means the server successfully found the requested document. What time was the document reply provided? The response time in Thursday, 7 March 2008 at 12:39 and 45 GMT. B. When was the document last modified? Okay, the document last modified on Saturday, 10 December 2005 at 18:27 and 46. C. How many bytes are there in the document being returned? There are 2,874 bytes. Question number D. What are the first 5 bytes of the document being returned? Okay, the first 5 bytes of the document are doc HTML public as seen at the start of the HTML content. Did the server agree to a persistent connection? Connection type is keep alive. That means the server keeps the connection open, so the user doesn't need to reconnect repeatedly. That's all from me. Thank you.
Hello, my name is Chintya Zahra Suhendri with study number 28025000000. I will explain how to develop a simple web server in Python. Explanation of steps is: first, creating server socket. The program creates a TCP socket that listens for connection on the localhost address and port 8080. Next is accepting connection. The server waits for a connection from the browser. Once the browser connects, the server revises the HTTP request. Next, checking request file. The server reads the request file from the file system. If the file exists, the server reads it. If the file not found, the server will generate a 404 not found error message. Next, sending response to browser. If the file found, the server sends the file with an HTTP 200 OK header. If the file not found, the server sends a simple HTML page with a 404 not found message. The last, closing connection. After the request is processed, the server closes the connection with the browser.
Hello, my name is Naura, and I'm going to answer some of the problems. The first problem, which is A user requests a web page that consists of some text and 3 images. For this page, the client will send 1 request message and receive 4 response message. So the answer will be false, because there are 4 connections, since each connection transports exactly 1 request message and 1 response message. So each object will have its one request message instead of there being only 1 request message. And B, text to be 2 distinct web page. For example, www.mit.edu/research.html, and the other one can be sent over the same persistent connection. The answer is true, because both of these web pages are on the same physical server, which is www.mit.edu. Now C, with non-persistent connections between browser and origin server, it is possible for a single TCP segment to carry 2 distinct HTTP request messages. The answer will be false. In a non-persistent connections, the connection closes after each connection. In this case, the connection will close once the first message is received, and there will be a new connection open to send the second message. Now to D, the date header in the HTTP response message indicate when the object in the response was last modified, which is false, because the date is the time at which the request was created and not when the object was last modified. Now E is HTTP response message never have an empty message body. False. Some HTTP response messages have an empty message body. For example, HTTP status code of 204 and 304 must not include a message body. Next, I'll be doing socket assignment 3 mail client, and this is the code. Now, first, we start by importing Python socket module, which allow us to create a network connection. And then we define the email body and an message indicator with /r/n, which tells the server that the message is complete. After that, we define the mail server, which in this case is Gmail's SMTP server on port 587. Then we create a TCP socket and establish a connection. After connecting, the server sends a welcome message. We receive and print this message to check if connection is successful. Next, we send the hello command to introduce ourselves. The server should respond with 250 if it accepts our request. Since Gmail requires encryption, we send the startpulse command to upgrade our connections to a secure one. We then specify the sender's email using the mail form command. The server responds with 250 if it's accepted. Next, we specify the recipient's email using rcpt to TO. Again, the server should reply with 250. We send the data command telling the server that we are about to send the email body. Then we send the actual email content followed by the end message /r/n ./r/n to signal that the email is complete. Finally, we send the quit command to properly close the connection through the email server. And that's about it.
Hello everyone, my name is Ukalvin and I'm here to answer the problem from number 4. And here's the questions. Let's start with the first question. Question A. To answer this, we look at two parts of the message. First, the get line, which specifies the path /cs453/index.html. And the second, the host header, which specifies the domain gaya.cs.umass.edu. Combining this, the full URL is http://gaya.cs.umass.edu/cs453/index.html. Next question, question B. To answer this, we'll look at the get line again. And this version is clearly stated here, which is http:/1.1. Next question, question C. For this, we look at the connection header. It says connection keep alive. The keep alive value tells us that the browser is requesting a persistent connection. This means the connection will stay open for multiple requests, which is more efficient than opening a new connection for each request. Next question, question D. So, the IP address is not included in the HTTP request message. The IP address will be part of the underlying network layer, like the IP packet header. So, we cannot determine the IP address from this HTTP message alone. And the last question, question E. To find this answer, we need to see the user agent header, which says, this tells us the browser is Netscape 7.2 running on Windows NT 5.1. Now, why is the browser type needed? First, it helps the server identify the client software. Second, it allows the server to customize responses based on the client's capabilities, like serving mobile-friendly content to mobile browser. And third, it's useful for analytics, helping server administrators understand what types of client are accessing their site. Next, I'm gonna answer the socket programming assignment number 2, which is UDP pinger. To answer this, we need a step-by-step to write the UDP-based ping client program in Python. The first step is to understand the requirements. First, UDP communication, where the client sends a ping message to the server using UDP. Second, 10 ping messages. The client needs to send 10 ping messages to the server. And third, the RTT calculation. For each ping message, the client calculates the round-trip time when the corresponding PONG message is received. Fourth, the timeout handling. If the client does not receive a reply within 1 second, it assumes the packet is lost and prints a message. And next, we need to write the client code. And here's the client code implementation. And here's what the client output might look like. So I'm gonna explain the code here. First, the socket creation. So a UDP socket is created using socket.socket, and the AF_init parameter specifies IPv4 and sock_dgram specifies UDP. Second, the timeout setting. The socket timeout is set to 1 second using client_socket.setTimeout1. Third, the ping message. Each ping message includes a sequence number and the current timestamp, time.time. Fourth, sending and receiving. The client sends the ping message using client_socket.sendTo, and it waits for a reply using client_socket.receiveFrom. And fifth, the RTT calculation. The RTT is calculated as the difference between the time the message is sent and the time the reply is received. Sixth, the timeout handling. If no reply is received within 1 second, a socket.timeout exception is raised, and the client prints a timeout message. Seventh, loop. The process is repeated 10 times. And 8. Socket closure. The socket is closed after all messages are sent. And the last step is to do testing and debugging. First, we need to test the client with the server to ensure it works as expected. Next, stimulate packet loss by introducing delays or dropping packets on the server side. And the last one, verify that the client correctly handles timeouts and calculates RTT.
My name is Dian and Lusiawati, and today I want to answer question R26 and P3. Why does a UDP server only need one socket? Because UDP is connectionless, meaning it does not require an exclusive connection between the server and the client. All communication can be done using a single socket to receive and send data to or from multiple clients.
Why does a TCP server need two sockets? Because TCP is connection-oriented, so it requires passive socket to listen for incoming connection requests from client, and active socket created for each accepted connection, used to communicate with a specific client. If a TCP server supports a simultaneous connection, how many sockets will it need? The server would need one passive socket to listen for new connection, and an active socket to handle communication with each client. The total number of sockets required is n plus 1. So the answer from P3 is when an HTTP client wants to retrieve a document from a URL and the server's IP address is unknown, the following protocols are required. 1. DNS, Domain Name System, is an application layer protocol used to map domain names. Example like www.example.com to their corresponding IP address. The HTTP client will send a DNS query to get the server's IP address. The advantage provided by DNS is that users do not need to remember the IP address but simply the domain name. Second, UDP, User Datagram Protocol, used by DNS to send requests and receive response. DNS typically use port 53. The third one is TCP, Transmission Control Protocol, used by HTTP to establish a reliable connection between the client and the server. HTTP typically use port 80 for port HTTP or 443 for HTTPS. Thank you.